as a 7th grade pre-algebra and 8th grade algebra teacher, I noticed that the students were not engaged during class lecture and note-taking. They also did not retain any of the information presented on a daily basis. I needed to help these students want to retain what they were learning. I wondered how we could pique their interest and see the classroom as a gateway to knowledge, as well as retain the information that was being taught. Whatever needed to be done seemed critical because the grades were slipping daily and school had just begun. I began to research and found that teaching through visual literacy enables students to decode and interpret visual messages, as well as encoded and composed visual communications in order to comprehend visual images and aids. Visual imagery within all curriculums was crucial to learning through all subjects during this media age, so that students may inevitably learn how to make important decisions based on the images viewed. So students were connecting visual and verbal illustrations when both were presented, and they have contextual representation that allowed them to form an accurate mental image that would then help them apply the concept or idea to long-term memory. I needed to help these students engage in what was being taught, as well as help them retain what they were learning. I then had to design cycles to research these ideas that I wanted to implement. I found a start doing education design and evaluation in the form of a flipped classroom. I furthered my own research in digital media and education applications because I learned that through this type of classroom, students could first learn through videos, tutorials, and hands-on activities, and apply what they have learned to the class lecture. I designed a plan that utilized the creation of a timetable to organize my planning. A Google Forms pre- and post-test so that I can collect data and evaluate it. A YouTube video for lesson explanation video. It basically explained what I expected in the project. A Prezi presentation for student summative feedback. This is where I learned what they liked and did not like. A Google Draw for student planning sheet. The students could plan their own ideas on a Prezi board. And finally, Pearson SuccessNet as a Web 2.0 tool. During the development of Cycle 1, I developed a website for students. I also incorporated Pearson SuccessNet as the students' math learning management system. The students first took a pre-test that was then followed by corrected learning within Pearson SuccessNet. Corrected learning helps students improve what the pre-test showed that they did not know. Students had to complete a weekly worksheet from Pearson SuccessNet as well as their modules to indicate retention of the information. Students then completed 2 post-tests, one through Pearson SuccessNet and the other as a Google form that I created. Students also created a Prezi presentation for summative assignment feedback. Cycle 1 gave a 50% increase. I was disappointed because I thought it should have been more of an increase. I also found that the technical difficulties left room for error, and the students stated that they did not understand the flipped classroom concept and that there was an abundance of information given to them at once. After discussing these issues with my peers and co-teacher, I decided to make changes for the implementation of Cycle 2. Before we could move on, we had to implement student training of how to conduct learning through Pearson SuccessNet and set rules in place for a smoother flipped classroom experience. Students would first take a pre-test, then watch videos, take short quizzes and tutorials in order to learn what was going to be lectured within the classroom. Students would then print out a correlated worksheet of their choice and complete it at a group table, where they were allowed to ask peers and teachers for any support that they needed to complete their worksheet. The changes that will be made to Cycle 2 would be the flood of hands-on activities and the elimination of the second post-test. The activities were added so that the students could include items that students could manipulate to find the answers. The last test was eliminated because the data from the Pearson SuccessNet and the Google form were basically duplicated. Cycle, students also completed a Pearson SuccessNet pretest and were prompted with videos, tutorials, and quizzes that helped them create background knowledge. Students completed a weekly worksheet on the topic, but we also provided them with manipulatives and plan worksheets that provide the students with hands-on experience during class time. We were able to give them short instructions, and students used the manipulatives and worksheets to solve the problems that were presented on the worksheets. Students first drew nets of three-dimensional shapes, then labeled them so they could later use the drawing and labels to create formulas and find attributes for the given three-dimensional shapes. The hands-on activities in collaboration with the flipped classroom created an 80% increase in students' grades. It also increases student engagement and participation. Therefore, the implementation of the second cycle impacted the students' performance the most because most of the issues were resolved and a pattern was developed. Overall, the implementation was a success for students' grades and retention of information. My project supported the dual code theory of visual literacy and how people learn and retain information. Since the children were able to hear it and see it and manipulate the items, they were able to retain more information that way. So this project was basically supported by my co-teacher as well as my principal and superintendent. This project helped me prepare to teach a flipped classroom this year with my third graders. I hope to use Pearson SuccessNet again and Schoology as an LMS for the Common Core curriculum. I'm also using this research to further study visual literacy in an EDS program. I'm now well versed in how to create, experiment, and create a process for a solution in my own environment.